All right, hi, my name is Marcus Suzuki. A lot of you guys already know me, and today I'm going to be going over how to factor using the GCF, using the X method, and using the box method. So you guys should at least understand the methods, okay? GCF, the X method, the box method, and we should also know when to use them, okay? So for number 3, we're just doing the GCF. That's all we're doing. So when we're doing the GCF, the first step is you always want to identify the numbers that are involved. So for the first expression on number 3, I see that we have a 6 right here, and we also have a 12, okay? So the biggest number that goes into both 6 and 12 is 6. So we're going to let that hang out on the left side, okay? Then after we take out the GCF, we always want to write down a parentheses, okay? And then it's almost like we have two empty spots here, okay? So we need to fill those in. We have two empty spots because we have two terms, okay? So for the first spot, I'm thinking, what do I have to put there so that when I multiply everything out together with the GCF, I get 6x, and that would just be an x, okay? And then for the second spot, I need to fill it in. So I'm thinking 6 times what would give me the negative 12, and that would be negative 2, okay? So I can clearly see here that I took out the 6 right here. That's the biggest number that goes into both 6 and 12. And then when I write down my parentheses, I also notice that when I double distribute it back, I get the original expression back. So that's how you always check it. Think in your mind, what you just wrote down, does it equal what you originally had? Okay. Now I'm going to go to number 5. For number 5, again, if you're only taking out the GCF, the first step is to identify the numbers. So here I have 4 and 10. I can always simplify this first. 4x plus 10x, what's that? That's just 14x here. Okay. Is there anything left to do here? There's not really a GCF that I can take out, but let's see what happens if I were to take out the GCF instead of simplifying. So I notice that both the numbers are even here, so if I wanted to, I could take out a 2. That's perfectly fine. 2 is the highest number that goes into both 4 and 10. And then I have 2 empty slots, okay? So the number of empty slots will always be the same as the number of terms that you have. So here I'm thinking 2 times what here needs to give me 4x, and that would be 2x. Okay, now I'm on the second part. Now I'm thinking 2 times what here would give me 10x, and that of course would be 5x. Okay, then if I wanted to, I could simplify what's inside the parentheses and write down 2 times 7x, and that gives me the same thing as 14x, or if I just simplified it from the beginning. Okay, so in this problem, it clearly shows that if I use the GCF and factor everything out, it's the same thing here as just simplifying the expression. Okay. Let's do another one here. So for number 16, this is you want to think about what type of problem is this, okay? So for number, or not 16, for number 10, okay? So for number 10, the first thing is you want to notice that there is a 1 in front of the x squared term. Actually, 11 has a 1 in front of the x squared term. Number 14 has a 1 in front of the x squared term. And so does 13. 13 also has a 1 in front of the x squared term. So if we have a 1 in front of the x squared term, which is the number one thing you have to notice, then what that allows you to do is say, okay, in this problem, all we need to do is the x method. So I notice that there's a 1 in front of the x squared term. What does that represent? That represents that I can do the x method, and the first step is to draw an x, okay? What goes on the top? What goes on the top is always the last number. So in this case here, it's negative 18. What goes on the bottom? It's always the number in the middle. So in this case here, it's negative 7. And then we have a specific thought process. So in this case here, I'm thinking, okay, what are two numbers that multiply to negative 18, but also add up to negative 7? And those two numbers in this case would be negative 9 and positive 2. Okay, So now that we know those two numbers, we can just write down the answer. So the answer in this case would just be x minus 9 times x plus 2. So again, let's just review what's happening here. I notice that there is a 1 in front of the x squared term. If there's a 1 in front of the x squared term, it means that I'm allowed to just draw this x. You recopy the last number on the top, then you recopy the last number in the middle. Remember, be careful. Sometimes I have the terms out of order. So the number always goes on the top. It's really the number in front of the x that goes on the bottom. So just be careful with that. And then again, what was the thought process? Two numbers that multiply to negative 18 that add up to negative 7. That happens to be negative 9 and 2. And once we are done with that x, we can just write down the answer here. And you notice it's almost like I just recopied the numbers here and here. I literally just recopied the numbers inside the x, or inside of this x right here. I recopied the numbers, and then I put an x in front, okay? Let's do one more here. So 11. So these are the easier type of factoring problems where there is what? A 1 in front, okay? So again, if there's a 1 in front, then the first step is to always just draw an x every time, okay? What do you put on the top? It's always the number at the end. What do you put on the bottom? It's always the number that's in front of the x, which is a negative 5, okay? What's the thought process? The thought process is I need two numbers here that multiply to negative 14 that add up to negative 5. So in that case here, that would be negative 7 and 2. After you're done with the x, you just write down the answer. So in this case here, the answer would just simply be x minus 7 times x plus 2. And then you're done at that point. That's it. So again, just a review, what just happened? The most critical thing about this is to know, all right, we're only allowed to do this x method when there's a 1 in front of the x squared term. So whenever you see a 1 in front of the x squared term, draw this x right here, recopy the last number on the top, the number in front of the x on the bottom. What's the thought process? We need two numbers that multiply to negative 14 that add up to negative 5. In this case here, that happened to be negative 7 and 2. Once you identify the numbers inside the x, you're done. That's it. So we recopy the numbers right here and here inside the parentheses, and we just put an x in front, and then that's the final answer, okay? All right, so we're not going to do 17. Sometimes, let's just do 17 real quick. Sometimes if you just understand what's happening, we can just write down the answer. So for 17, what are two numbers that multiply to 8 that add up to negative 6? Okay, that's just x minus 4 times x minus 2. So sometimes once you start getting better at this, you can just start writing down the answers because we understand that the numbers have to multiply to the last number, but add up to the number in the middle, okay? All right, so now we want to do some and understand how to factor out problems that don't have a 1 in front, because all the ones that we've done so far have that 1 in front, okay? Okay, so I'm going to start with number 10. So how is this problem different than the previous problems? This problem is different because there's a 3 in front. It's no longer a 1. So we have to sort of change up what we're doing, okay? The first step is still going to be an x, so we still draw an x. Okay, but what goes on the top now? What goes on the top is the multiplication of the number in the front and at the end. Again, be careful. Sometimes these problems are going to be out of order. So it's really, we have to multiply the number in front of the x squared term and also the constant, in this case, which is a 4. Okay, so on the top, we're going to write down a 12, and on the bottom, we're going to write down a negative 8. Okay, so it looks very similar to the last problem. Now we need to be thinking, okay, what are two numbers that multiply to 12 that add up to negative 8? That would be, in this case, negative 6 and negative 2. Negative 6 times negative 2 is 12, but negative 6 plus negative 2 gives us negative 8. Perfect. So now what do we do with that information? Okay, so remember, we can't just write the answer as x minus 6 times x minus 2. That's not going to work here. That's what we did before. We can't do that here because the number in front of the x squared term here is not a 1, it's a 3 here. So it's a different process. So what do we do now? We have to write down the box, okay? So now we write down the box. In the top left corner, we always want to write down the x squared term. So in this case here, it's going to be a 3x squared. What do we write down in the bottom right corner? We always want to write down the constant. So in this case here, it's a 4. And whenever we see the x squared term, you want to think about, okay, what multiplies out together to give us 3x squared? In this case here, that would just be a 3x and an x. So we want to write that down. Now the challenge is going to be, how do we fill in the rest of the box? So we want to start with the constant here, and we want to think about, okay, does 3 go in evenly to -6, or does 3 go in evenly to -2? So 3 goes in evenly with -6. So those are the ones we want to align together, and we're going to put them in the same column. The only thing is you don't want to forget to put the x when we are putting them into the box. So I'm going to put in a -6 right here, attach the x, and if you notice, the 3 and the -6x terms are lined up because the 3 goes into the -6 nicely. Okay, there's only one other spot for this -2 to go. The -2 has to just go into the only remaining spot, which would be right here, but don't forget the x, okay? Now is where we actually start putting in the answers, okay? So now at this point, I'm thinking, okay, how many times does 3x go into -6x? That's -2 times. So I'm going to put down a -2 here, okay? Then after that, I'm thinking, how many times does x go into -2x? That would also be -2 times. Great. So then what's my final answer? My final answer would then be y equals 3x minus 2 times x minus 2, okay? Now, you want to circle it, and if you ever don't know if it's right or you want to check it, you can always double distribute and check your answer to make sure that it's right. So if you were to double distribute this term, it would exactly come out to this part right here. Okay. I'm going to do one more, and then that will conclude the video. Okay, so I'm going to do number 11. So for number 11, it's always like, what's the first step? We always want to identify if there's a 1 in front, because depending on what's in front of the x squared term, that tells us what we are allowed to do. Now, whenever we're doing any factoring problem, you always want to see if there is a GCF first. That's always the first thing we want to do when we factor. In this case here, there's no GCF, so we don't have to worry about that. There's no number that goes into both 3, -2, and -5. That number does not exist. So we just go straight to the method that requires us to use the 3 in front. If there is a number that's not a 1 in front of the x squared term, the first step, it starts the same way. We just draw an x. So on the top, we always write down the number where the first and last terms multiply. So that would be -15. On the bottom always goes the middle number, which is a -2. Now we're thinking which two numbers multiply to -15 that add up to -2. That would be -5 and 3 in this case, because -5 times 3 is -15, and -5 plus 3 gives us -2. Okay, so what's the answer here? The answer is not x minus 5 times x plus 3, because again, we're dealing with a problem where there's not a 1 in front, it's a 3. So if it's a different number in front, we have to draw a box. And then the hardest part about drawing the box is we just have to fill it in correctly. So in the top left corner, we always want to draw the x squared term. In the bottom right corner, we want to write down the constant. And then we want to write down what multiplies out to the x squared term. In this case here, we can just say it's a 3x and an x, okay? So now is the challenge. So now we want to be thinking, okay, what do we put in the other boxes? Well, let's see. You want to start with a constant in front of the x. That's probably the easiest. And we want to be thinking, okay, does 3 go into -5 better, or does 3 go into 3 better? 3 obviously goes into 3 better, so we put it right here with an x attached. And if you notice, the terms that go together nicely line up in the same column. Okay, so then where does the -5 go? It just goes in the last box available. So I'm going to put a -5x there. Okay, and then the last step is to write down the answer. So now the thought process is 3x times what would give me 3x? That would be a 1 right here, okay? If you notice, I'm dealing with a column at a time. I'm looking at these two guys here and putting the answer right here, okay? Now I'm thinking x times what here would give me this -5x term here, and that would be -5, okay? So at this point here, I can just write down my answer, and my answer would be what's on the top. That's a 3x minus 5 times what's left over, which is right here, and that would be x plus 1. And that would be the final answer. And if you wanted to check it, you can always double distribute here. If you were to distribute this, you'd get 3x squared plus 3x minus 5x, which would give you the -2x here, and then the -5, okay? All right, that concludes the video, and then I'm going to do one more video for some extra examples. All right, thanks, bye.